So we were studying about Python memory management. Now we will be looking into garbage collection. First of all, I would like to mention 2 or 3 points which would be helpful in understanding this. तो Python में कुछ ऐसे concepts है which we should know to understand this. So let's say someone writes x is equal to 1. So we know till now one integer object would be created and x would starts to point to it. And if I ask you the question, how many variables are pointing to this integer object? So the answer would be 1. And Python names this as the reference count. कि किसी के object को how many variables are pointing to some object is named as the reference count. ठीक है? This is the concept number 1. Now the concept number 2 is Python says, let's say we delete x. So now एक भी variable point नहीं कर रहा है इस object को. So the reference count drops down to 0. So immediately what Python does is clears this memory. So memory में जहाँ पर भी ये one object heap memory में created होगा, Python उसको जाके clear कर देता है. ठीक है? So this is how Python manages memory with the help of this reference count. But there is a special case when सिर्फ ये reference count drop down to 0 and then clearing the memory is not helping. Now what is that special case we will be seeing here. एक class definition है like node class, and then we are creating two objects. Node 1 is the label to object 1, node 2 is the label to object 2, and then what we are doing, node 1 dot next is equal to node 2 and node 2 dot next is equal to node 1. To visualize this, look at this picture. Node एक class था, ठीक है, and it have two values. It have two properties, value and next. Now node 1, when we created, it have value 1, and in the next line we wrote node 1 dot next is equal to node 2. ठीक है? So you see this red line, it's pointing to this, right? Similarly node 2 का value 2 है और इसका next is pointing to this, and we have these two variables which are node 1 and node 2, which is pointing to their respective objects. You see over here node 1 and node 2. ठीक है? अब if I ask you what is the reference count of these two objects, so node 1, if we look into it, so there is a variable which is pointing to it and there is another object which is pointing to it. So its का reference count क्या हो गया? 2 हो गया. Similarly for node 2 एक variable है. Similarly for this object there is a variable which is pointing to it and there is another object which is pointing to it. तो उसका भी reference count 2 है. Now let's say someone does del node 1 and del node 2, जो कि कोड में लिखा हुआ है कि now someone does this. इसका मतलब क्या? The variables which were pointing to these two objects are no more in the namespace. We have deleted that. So now these two objects are left in the heap memory pointing to each other. इसका मतलब reference count 2 से 1 तो हो गया क्योंकि इनके variables delete हो गए, पर अभी भी ये मेमोरी में एग्जिस्ट करेंगे. क्यों? क्योंकि इनका रेफरेंस काउंट ड्रॉप डाउन टू 0 नहीं हुआ है, विच वॉज द कंडीशन थ्रू विच पाइथन कह रहा था कि अगर रेफरेंस काउंट 0 हो जाएगा तो हम मेमोरी क्लियर कर दें. पर इन केस में सर्कुलर डिपेंडेंसी क्रिएट हो गया, टू ऑब्जेक्ट्स एक दूसरे को पॉइंट कर रहे हैं, सो रेफरेंस काउंट स्टिल 0 नहीं हुआ है. सो इस केस में ना ही ये वेरिएबल कोड के थ्रू हम लोग को रीचेबल है और ये वेरिएबल इज टेकिंग अप सम मेमोरी. ठीक है? सो दिस इज नॉट एफिशिएंट. सो इस फ्लॉ को ठीक करने के लिए पाइथन हैव दैट कॉन्सेप्ट ऑफ गार्बेज कलेक्शन. ठीक है? दिस इज व्हाट पाइथन्स जनरेशनल गार्बेज कलेक्शन. विल बी कमिंग टू इट, बट बिफोर दैट एक ओवरऑल आइडिया आई विल बी गिविंग. तो पाइथन गार्बेज कलेक्शन फॉर सर्कुलर रेफरेंसेस. You saw that it was a circular reference kind of thing, right? So there are few steps involved. Number one is periodic execution. The garbage collector runs automatically at intervals. मतलब at intervals garbage collection अपने आप चलता है Python में. It identify the object groups which reference each other. ठीक है, वो सर्कुलर रेफरेंस वाले ऑब्जेक्ट्स या फिर एक दूसरे को जो ऑब्जेक्ट पॉइंट कर रहे हैं उनको वो आइडेंटिफाई कर लेता है. देन इट चेक्स इफ एनी कोड कैन रीच दिस ऑब्जेक्ट. तो here no code can reach this object. ठीक है, so the next step would be break the cycle. If no code then if no code can reach them, it breaks the cycle and frees the memory. Free the memory. The memory occupied with this object is freed. Very simple. ठीक है, so this is how garbage collection overall works. Now coming to the details, let's say someone asks you that what is happening, what is the logic, or you could say algorithm through which Python handles all this. ठीक है, so Python have this concept of organizing the objects into generations. एक young generation, एक middle age और एक old generation. कैसे? So let's say you are writing some code. So in Python everything is an object. तो you write some code तो फिर object बनते जाते in the memory. And let's say object 1, इस तरह से करते करते 700 ऑब्जेक्ट्स हो गए. ठीक है, so this is called as young generation. Now let's say another object is created 701th. Now what happened कि सबसे young जो object है वो कौन सा है, ये वाला है. So this will come into young generation. ये young generation में this 701 will be included and ये 1 now will go to mid age. ठीक है, so इस तरह से चलता है. Let's see what is written over here. So Python have this set कि it will apply garbage collection on young objects, young generation objects first and most frequently. Then middle age, then old. So let's see. Generation 0 is young, newly created objects, most frequently collected. Well, Python have this. Generation 0 को वो सबसे frequently collect करेगा जिसका threshold है 700 objects. Once you get 700 new objects, तो फिर क्या होता है कि Python अपना garbage collection चलाता है and उन 700 objects में whatever meets this condition that कुछ circular dependency is created and that object is not reachable by a code, तो Python clears it. ठीक है, let's say this is the case, या फिर let's say some objects survive this young generation and now they moves to the middle age, right? So when this garbage collection of middle age generation object runs, ये तब रन करता है when 10 times this young generation garbage collection have been done. So हर 10 साइकिल पे ये एक बार चलेगा. ठीक है, गार्बेज कलेक्शन सबसे ज़्यादा इस पे चलता है and every 10 cycles one middle age cycle runs and every 10 of this middle age cycle one old generation cycle runs. ठीक है, so these are rarely collected. इसका threshold is 10 generation 1 cycles जब चल गया हो then this will start to run. ठीक है, so this is how Python internally runs this garbage collection thing. Now coming to the code part, like there is a GC module in Python, ठीक है, and inside that you could write some code to look through what is happening and do some printing of logs. So basically कुछ methods I have written over here which you could go through and see how this is working. So gc.collect, very intuitive कि force collection immediately. So you just have to import the module and gc.collect run कर दो तो it will return कितने objects free किए हैं उसने, which were going through that circular dependency thing, ठीक है, and for not reachable via code, ठीक है. gc.collect very intuitive, gc.disable or enable. So if you want to turn off or on automatic garbage collection, then in that case this is helpful. Then post that gc.get threshold, ठीक है. As I told over here कि this is the threshold, young generation का threshold 700 objects है. So once 700 objects are created, then only generation 0 garbage collection will start, ठीक है. वैसे ही when 10 times generation 0 cycles have been completed, तभी mid aged का GC चलेगा, ठीक है. And similarly for generation 2, when 10 mid aged have ran, तभी ये old के लिए चलेगा. So you see यहाँ पर threshold mention है. When you write gc.get threshold, 700 objects creation के बाद gen 0 चलेगा. Gen 1 would be running when 10 cycles of gen 0 have completed to run, and gen 2 would run when 10 cycles of the previous generation, which is gen 1, have completed. Similarly gc.get count पे आते हैं. So it's basically a snapshot, ठीक है, which is like you are asking the gc module to give me the current snapshot that in all the generations what is the present state. So if you get an output like this 450, so 450 450 comma 3 comma 0, so gen 0 have 450 objects created. Gen 1, you see 3 is the count, so basically 3 times gen 0 have ran, and gen 2 0, which signifies gen 1 का अभी भी एक भी cycle नहीं चला है. So that is the significance of this. Now coming to the final part, what is the conclusion? So Python has this two-tier memory management system. So one which I explained at the beginning of the video was reference counting, another which we have seen in this video, garbage collector. So reference counting have this simple mechanism, जब RC drop down करेगा 0, then Python will clear the memory. Fine. Garbage collector have a different mechanism, generational mechanism, which you have seen over here. And as per this, the circular references जो GC से नहीं handle हो रहे थे, that would be handled, and it ran periodically and automatically, because whenever the threshold hits, the GC ran. So that is the concept. And if you see, it's faster because as soon as the reference count drops down to 0, तो reference count वाला faster है, क्योंकि जैसे ही RC 0 हुआ, वो Python memory clear कर देगा. And this periodically run करता है, therefore it's quite slow. And we have an analogy, like the reference counting, we could see it as regular trash pickup, so it's instant. And the garbage collector is special cleanup which runs periodically. So that's about how Python manages memory via reference count and the garbage collector.